Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In this video, we are going to talk about a new framework, Data Solution Lifecycle. This is a framework that I have put together based on my academic and industry experiences, and I believe this framework, it's kind of an update or a more granular and more detailed version of CrispDM that we have been discussing in the past couple of my videos. In this one, there are a few different things. It has more updated and more granular processes and things that happen for the data lifecycle, for the data solution. It also has an emphasis on the deployment part that, as I said, it's kind of missing in the CrispDM. All right, let's get started. All right, so here we go. This is what we are talking about in this video, Data Solution Lifecycle. We will have more of a conceptual video in this video. In the later videos, we will kind of like dig deeper in different elements of Data Solution Lifecycle. However, here and there, we are going to need a case study. And the case study we're going to be using is employee churn prediction. This is the large overview of Data Solution Lifecycle. It has five parts, 5 stages, if you will. And it starts with problem understanding, the associate number 1 with the color green. And this part is basically coming to the idea or coming to the thought of that there might be a problem that we can solve using data that can add value for us. And then the second associate or purple associate is data acquisition and integration. This part is basically working with the databases to bring together the sources of data that are going to be conducive to help the problem in stage 1. Stage 3 is the notorious data cleaning and massaging. And in this stage, we basically have a version of our data that has come from a stage 2, but we improve this data to become the second version of our data that is going to be more conducive for our modeling. And it's going to support our modeling the best possible way. Then stage 4 is the modeling and validation. This is the stage that most people want to jump in as becoming data professionals. However, as you can see, there are 2 prior stages before you even starting on this modeling and validation stage. And then lastly is the stage of 5, deployment, which basically bringing the model, bringing the value that we have created from modeling and giving them to the organization and the people of organization for them to be able to reap the benefits of those models. So that's Data Solution Lifecycle. And of course, this cycle will continue once we have that application endpoint. Then organization might come up with another problem statement. And then this will continue for a data solution lifecycle. Each of these stages, 5 stages, can be drilled down further, right? So this is the more drilled down version, more granular version of the same data solution lifecycle. But each part of these phases, except for phase 4, which is kind of like similar to what we saw here, like modeling and validation, it has more granularity, and we will be able to talk about them in this video. Before we get into the weaves of this different parts of each of these stages, let me bring this to your attention that this data lifecycle solution is coming from my newly published book, Optimizing the Big Data Problem Statement. And this is, like I said, is a framework that I have put together, and I believe as it comes from my industry and also academic teaching and research experience, I believe this framework can be very valuable when you go about making sure that you are solving the right problem statement for your big data. So if you're interested about knowing more about this framework and other aspects of this book, please go ahead and take a look at it. Let's talk about the employee churn prediction. So let's say we are assuming that we're working for Amazon, and Amazon would like to know if their employees are likely to churn or are likely to stop working for them. Why Amazon would care about this is because when employees at every stage or every levels of organization, when they join, there is some cost that is incurred for the for the company Amazon, for their training. And also there is also another cost for finding a replacement for these employees. So Amazon would like to be able to, of course, I'm pretty sure, would like to be able to reduce these costs. One of the ways that they can do that is by making sure that they do not lose employees. This is a case study. We assume that Amazon was trying to do this, and this is basically, in this case study, our data objects are employees, right? So we are modeling employees, and then the target value, the target prediction, or the target or like dependent variable here are churn or not churn. We are basically predicting if our employees are going to churn or not churn. And the sources of data that we have: demographic information, employees performance review, and employees operational data, right? For instance, these are the three possible sources. This is not to say that these are the only sources, but these are the sources that we can right off the bat ideate or think or hope that they're going to have some patterns to help us with this prediction. Now let's start talking about different parts of this cycle, data solution lifecycle. So always we start with the conceptual endpoint. This is the understanding that we might be able to take advantage of some data. At this point, we haven't come to our problem understanding or our viable business problem. What we have come across is a thought and an idea that this might lead into a viable business problem. For instance, at this point, this could be a thought in a sort of like a higher up or one of the managers at Amazon that we might be able to get some values from our data to be able to avoid our employees churning on us, right? So that's kind of like an idea more than a problem statement. After that, of course, we've got the business understanding or problem understanding. So at this point, we have to pay attention to many different things, right? So the viable problem statement, the guy we have here, right, doesn't just come to us. I mean, if you're experienced, you will have these processes in your mind, right, for you to get to this viable problem statement. But this is the process that you will need to go through, right? So first and foremost, you will have to understand business understanding, and we did talk about why it is important for us to avoid letting our employees go, right? It's because of the cost, right? So if you can reduce that cost by any way, by any solution that is economical, it doesn't cost us more than the cost we're already incurring, so it's going to be a better route for us, right? So that's the business understanding. And then the problem, at first in the conceptual endpoint was, we have data, we have customers that are churning on us, can we use this to improve it, right? So that's sort of like the conceptual idea. But then the problem then becomes, do we have, for instance, can we create a prediction model to predict customers churning, right? And then we now have to pay attention, do we have the data to be able to do this? Like, can we find data, or can we afford having data that can find patterns for this problem? And then by going through our data and being able to see if the data is economical enough for us, if we have it. And for Amazon, probably the answer is yes, because their business is based on data. Then we come to a viable problem statement, right? So this is the process that one needs to go through when they hit upon an idea. That idea turns into a viable problem statement or not, right? And then there is another thing we have to pay attention here is that we might think that we have a viable problem statement, and after solving this problem, we might realize it wasn't a viable problem statement. So it's really important for us to take our times in this stage, and be realistic, and also pay attention that not to be too rigid by not wanting to take risks. So there is definitely a balance here, and an experienced data practitioner can be of highly value to be able to come to this viable problem statement or not a viable problem statement. So after we do have the viable problem statement, we move to the second stage, which is data acquisition and integration. This is where we hunt data. We go through our databases, and we go through the third-party data. We go through the internet, everywhere we can lay our hands on data. Even we might want to start collecting some data, or even we might want to generate some synthetic data, right? So you have data acquisition, data filtering, data integration, synthetic data creation, right? All of those are important. And then once you have them, then you don't need everything. You might have to filter based on what you need. And also, some of these sources are not the same source, so you might have to do some integration, some mixing of these data that is going to be beneficial for your analysis, right? So for instance, let's say in this case study, the employee churn prediction for Amazon, this is basically the data that we come at the end of stage 2, right? So we say, okay, the age of the employee, their tenure, the amount of the number of months they have been with us, their base salary, their peer promotion, the number of percentage of their peers that have been promoted, their learning hours, how much we invested in them for their learning, their daily message sentiment average. Let's say if they are messaging each other, it's kind of like, it depends on their role, but if their role is involved at sending messages, their sentiment of those messages, and if they have churn or not in the last 6 months, right? So that's kind of the blueprint of the data we are envisioning to have after this stage. And then we move to stage 3, which is data cleaning and massaging. The end goal of this stage is to improve the quality of the data we get from stage 2, right? We've got some very famous components here, such as data cleaning, data validation, handling missing values, handling outliers, but also we get the feature extraction and data transformation that may not be as famous. So I'm going to skip the ones that are famous. Let's talk a little bit about data transformation and feature extraction. And we're going to do that by a way of example, right? For instance, this daily message sentiment average, right? This basically is going to be a time series of the employees' daily averages, right? So for instance, let's say this is the for one employee, this is their sentiment daily averages for 6 months, right? And this is basically 180 numbers, right? So this is not one column of data, it's 180 numbers, right? Can we use this in a classification model? And the answer is we could, but it's so many attributes, right? So many independent attributes. And it's going to be hard for our algorithm to be able to use these numbers. So what we do here, we do something we call feature extraction, right? So for instance, we fit one of these 3 models, right, to this attribute, right, to these 180 numbers, right? So we either use the mean, which the number of parameters is going to be 1, the top one. We use the mean of all of these values, right? So we just the mean of all of those 180 numbers becomes one extracted feature from all of these 180 as our independent variable. Or we fit a line which has intercept and slope, which is the second one, right? Or we even go higher in our dimension of our model, and we use a polynomial model, which basically has x power to 2 and then x and then our intercept, right? And we can see with the polynomial we've got a better fit. However, it might be more difficult to interpret. The linear model, it's much easier to interpret. We've got an intercept and we've got a slope. So let's say we go with this feature extraction. So we choose this, right? So if we choose this, then instead of this 180 numbers, we're going to have one intercept and one slope for every one of our employees, right? So that's called feature extraction. How about data transformation? Well, I mean, one thing is feature extraction is kind of a data transformation, but data transformation is a broader process. For instance, let's say we want to see this data transformation. So this is the base salary of all of our employees in Amazon, right? So we can see that most of our employees are grabbing this much salary or getting this much salary, and there are some flyers, and these flyers have values that are way different than most of our employees. When we have situations like this, what happens is that because there is such big difference from the outliers or the flyers, then the difference between the normal salaries will not be able to show itself, because with machine learning algorithms, we're working with numbers, the difference between the numbers and the relative larger or smaller values between these numbers. So with this, what we basically are saying, we're basically distinguishing between the small number of employees that are very different and the majority of our employees, right? So that's basically the only thing we are doing here effectively. So for us to deal with this situation, we transform the data using log transformation. And that's when we manage to transform our data by doing the log of all of those values, and then we get this very healthy looking normal distribution. And instead of using the original salary values, we will use the log transform salary values. It basically allows us to have relative differences between all of our employees, and at the same time actually have this value of base salary to be able to have some impact. All right, so after our data is ready, we improve the quality of data in stage 3, then it becomes the modeling and validation. I mean, based on the problem statement you might have supervised models, unsupervised models, optimization models, visualization. Yes, visualization is also a model. Any types of models it can be here. And you've got validation of that model based on whatever model that you have. If it's optimization, are you improving your decision-making process? If it's supervised learning, your accuracy, your adjusted R-square or R-square or RMSE, or if it's binary classification, recall F-score, whatever metrics that you are using. Visualization, are you capable of seeing what you wanted to show, right? It's visualization, and you are an audience yourself. So once we have that, right, once we got that modeling, this is where most of the time we will have an answer to if our viable problem statement was actually viable, meaning we are capable of solving it, right? So this is where we know that yes, we can solve the problem, or no, we cannot solve the problem. If we can't solve the problem, then we go to the deployment. The sort of like from here before, there is like a small project here, right? This is known as creating an MVP, minimum viable product, or proof of concept, POC. Once we create that, then we basically by that it gives us the power to convince the higher managers or convince our investors to give us some money to go into the deployment, right? In the deployment, basically, which is the next stage, we have two substage. I call these two substage as data engineering and AutoML, auto machine learning, right? So let's dig deeper into each one of them. With data engineering, basically, we want, it's different than, the stage 2 and stage 3 of data cleaning and data integration, data cleaning. This here, it needs to be orchestrated. It needs to work without a flaw. It needs to have the data that you need for your model training and for your application whenever it's needed, right? So you don't have, when it comes to deployment, you don't have to you don't have the time to clean the data or integrate it. Everything must have happened already behind the scene. All you're going to be needing is to request it. So for that, the data engineering part needs 4 elements. It's called data ingestion. It regularly, as often as it's needed, go grab the data from its source, right? So it's ingesting the data, and then whenever it does that, or whenever it's necessary, it transforms the data and it keeps the data in the storage, right? Whenever it's transformed, it's ready. And then it also needs an element of serving, right? I want the data to modeling, right? I need data for validation. I need data for model selection, right? Whenever you need data, you come to the serving and say, okay, give me this data. The AutoML part is one of the customers of the data engineering serving part, right? So in this part, let's say we try to model based on our problem statement, and we grab the data, and then once the modeling is done, we push our model to the validation, and then we also from the validation get some data for validation, and then in this part we basically validate if our model is any good, and then we push our model to the model selection, and in this model selection, whatever model we've had in the past and whatever types of models, it could be different models. This model selection based on criteria is going to be selecting a model that is the best, right? And that's the model that we are going to be using. And so whenever application needs a model, it pings model selection, ask it, okay, give me the best model that I need to use for this right now. So that's the 2 parts of the deployment. And once deployment is done, then we've got the application endpoint. Basically, application endpoint gives the model that the AutoML has created with the help of the data engineering to just bring it to the application. So for instance, let's say in Amazon, it could have many different applications, right? For increasing salaries, for sending messages, automated messages, it could have many applications. But for instance, one of them could be this. Every time the managers are about to have a sit down with their employees, right? As a part of the package we give the manager to be prepared to talk with the employee, we will also get a report from this solution, which is how likely this employee in question, is at the risk of leaving us. And that could be very helpful for the managers in their discussion with the employee. So we are coming to the end of this video. Let me bring this to your attention that this basically was a summary of chapter 3 of this book, Optimizing the Big Data Problem Statement, that I have recently published. So if you want to get a sort of like more detailed version of what I'm doing here in this video, feel free to get the book and read it there. All right, in this video, we talked about data solution lifecycle, and we went through its 5 stages, and we had kind of a problem, kind of a case studies. Whenever we needed more details, we used that case study. We didn't kind of like, it wasn't all about that case study. It was just like whenever we needed it, we used that case study. Anyway, in the future video, we are going to finish the crisp DM cycle. Like we have been talking about the crisp DM, and then we're also going to be getting in more details of the data solution lifecycle. All right. Looking forward to seeing you in those videos.